Okay, so welcome everyone. I'm here to talk about Infer, which is a static analyzer.
Speak up a little bit.
And I will speak up a little bit. And so why are we in this room today? It's because programming is hard. It's incredibly hard, and it's when you program and you want to avoid bugs as much as possible, you need to think of all the possible cases. In the worst case, you need to keep track in your head of the possible values that this function can be called with, or that can flow through your program from the user. If something can be null in your program, it will be null someday for someone, and your program will crash. And if you ship bugs to your users, then they won't be happy, and they sometimes need to take active steps to get rid of the bugs, for instance, upgrade their app or services. So what do we do to combat that in engineering? Well, we try to have the best code. Yes. So we develop coding practices. We add tests to test functionalities. We try to architecture the code in a way that minimizes bugs at the boundaries. We add more tests. And then you can also pick a language that has more or less more or fewer foot guns or pitfalls. Like, does your language allow null values, allow objects to be null, or if you use Java and you manipulate files, for instance, you should use try with resources so that you don't forget to close the files. And your language can have a more or less rich type system, which will also prevent a range of issues. Although you cannot always choose your language, there's tons of code out there. I'm sure you all work with horrible code bases from day to day, sometimes in your life. Or you have to pick a particular language to please a particular vendor or things like this. So in this talk, I will talk about static analysis. And it's just one additional way to give signal to developers that the code is good to go and doesn't have too many bugs. So in contrast to testing, static analysis of the family I will present attempts to check all program paths and all values at the same time and ensure that the program will work in any case. And you can also think of it sometimes as a palliative from tricky language features. For instance, if your language, for some reason, decided that all objects could be null and there's no way to know except to test at runtime, then static analysis could be a way to make sure that things are not null at the point where you difference them. So Infer is such a static analyzer. It's written in OCaml, but that's not important. It analyzes Java and the C family of language, C, Objective-C, and we added C++ support last year, and we're still working on that actively. And the main characteristics are it's interprocedural, so it will track flow of values from functions to functions and across translation units to find inconsistencies in the code. So something can be null deep inside a function call, and you use it deep inside another function call. Infer should catch that. And the other characteristic I want to stress is that it's incremental. So it's very fast at analyzing code changes. And that's very important for the way we use it at Facebook, for instance. So Infer is on GitHub. It has a pleasing amount of stars. This is from back when we open source, so this is a bit stale, but people at the time seem to like it. Since then, we've opened collaborations with other companies, so Infer is not used only at Facebook. It's used at Spotify, at Q1, at Uber, and more and more. If you want to use Infer, you can visit the website, and you have two options. You can get started on your code base, or you can even try Infer in your browser if you want to quickly test some functionalities. This is an old version of Infer, but it gives a good idea of what it can do for Java. So that's it for the introduction. I will start with a quick demo. So this is a tiny toy project. It's a bunch of C files and a make file. If I tap make, it compiles the files. And if I want to run Infer on this, first I have to make clean. So that's because Infer will just you pass the build command that you use for your project to Infer, and it will hijack the compiler and the compilation tool and the build system. Sorry. To figure out what it needs to build, and then it will hijack the compiler calls to read the source files itself and analyze them. So here we see that it detected we're in make mode. This is make talking, saying it's compiling 3 files. And then once these are captured, we say, then the analysis starts, and here we find 3 issues. One is null dereference, so you get a source excerpt here, so it says pointer Bob, which I got here, is dereference in here and could be null. Also, incidentally, you're leaking memory, and so this one we can understand straight away. We declare a null pointer and we dereference it, and so Infer yells at us. So we can explore the reports using another tool that ships with Infer called Infer trace bugs.
Will you try to keep the terminal up at the top?
Yes. I will try. So, sorry. So, yeah, it displayed a big trace, which you can read through. It's informative, but let's do it in Emacs instead. So here it repeats the bug, but then we see the actual symbolic trace. So these are the steps of symbolic execution that Infer followed to detect an issue. So it says, I entered in this other procedure, and if you go inside, it's in another file, and it analyzed also that it made the connection between the two. And so you call this procedure, which calls malloc. There's this suspicious bit of commented code, and then here you get to here, and the trace says condition is false. So p not equal to null is false. So at this point, we know p is equal to null, and we return p. We get out of the function, and now what that means is that Bob is null here. And then we get into getAge, which is again in another file. And what we see is this procedure just dereferences the pointer. So there you go, you have a null dereference. So what we're going to do to fix this is assume that malloc doesn't fail. And then we're going to rerun Infer. And if I rerun make here, what you expect is that only the file that I changed will be recompiled. And so you can tell Infer that exactly that it has to capture some reactive change. It has to react to a change instead of doing a full analysis. So it will not discard what it captured before and what it analyzed before. It will just capture whatever is new. So here, just person.c, and reanalyze just that file, and the files that depend on it. So here, in particular, it reanalyzed bob.c because it depends on person.c. And so now you see that there is one fewer bug listed here because Infer reanalyzed all the things that depend on our change. So then the memory leak is easy, should be easy to fix. We don't need to look at the trace for that. So here we get a new object Bob, and we get some field of Bob, but at the end, Bob is still live, and we haven't freed it. So what we need is we need to remember the age of Bob somewhere. Free Bob. Return I think that's C. If I rerun again, I only get my this issue that I don't believe is a real issue, so I will leave it here. Okay, so this is a quick glimpse of what Infer can do. Here it was very simple make project, but you can have in practice it runs on very large projects, and it supports an array of build systems. Check. And the kind of bugs it finds, we'll go over quickly. there on the website. There's more explanation there. But briefly, for C, C++, there's another reference, memory leaks, and resource leaks. So if you open a file and you forget to close the file descriptor or things like this. So very, very akin to memory leaks. For C++, it doesn't quite do array-bound checks yet. That's a hard problem in static analysis, so we haven't quite come up with something we're happy with yet, but stay tuned. But what it can check is, which is a pattern that happens sometimes, is the vector is actually empty and you try to access an element in it. And so this is easier to check, so we have that for now. It also detects static initialization, although fiasco. If you've been hit by it before, you know it, and I don't need to explain. And a bunch of other things. We do Objective-C because we run on mobile apps for iOS. So there, the only thing I'll mention is that Infer detects retain cycles, which are cycles in the memory that defeat the simple counting garbage collector of Apple. So you don't want that, and so this is an example of things that static analysis can help with if your language has some issues like this. And for Java, there's a GC, so we don't care about memory leaks, but we still have another reference on resource leaks. There's a taint analysis, if you're into that. That's an interesting checker that came for some engineers asked us to do that at Facebook. So this is something where you can annotate some methods as performance critical in your code. For instance, things that run on the UI thread in a mobile app, and you can annotate other methods as expensive. And then Infer will check for you that there is never a call chain from a performance critical method to an expensive one. And others. Again, see the website. We have also some Android specific checks like context leaks and fragment retains view. So I mentioned that this was just a toy project, but for instance, we run on DuckDuckGo, which is the app for this DuckDuckGo browser search engine. Sorry. So here's an example bug. So the report by Infer was there's a resource you acquired at line foo, and it's never released after some other line. So what that means in the code here is we allocated the resource here by doing this DB query. And here there's an if branch. And in that if branch, you can return from the function before you call close. And so here you leak the cursor. So that's bad. Don't do that. Another example, just quickly. So here what do we have? It says this feed object here from this nested method call can be null. And then it's the reference. So let's see, it goes into the function, which initializes things to null. Then it does a DB query. There's an if. At this point, the cursor can be empty. And so we don't never enter that branch. And we get the finally. We close it, and we return out, which we never changed from the beginning. So it's still null. So here, the end of the story is feed object is null at this point. And we go inside this other function, and Infer, when it analyzed it, it saw that one of the things it does is it dereferences its parameter. So here you got an NPE as well. Beam. OK, that's it for the demo part. So I will just say a little bit about how Infer works internally. Not going into the details of symbolic execution algorithm or anything. It's just the various phases of the Infer runs. So that's helpful to understand how to use it, I think. And then I will tell a little story of how we use it at Facebook. And that will be it. So the architecture of Infer is roughly this. So this is your program. It's a bunch of source files and a build system that knows how to compile them. And these are the things that Infer supports in blue. And so the first thing is it goes through the front end, which knows how to drive the build system to to get to the source files, and it translates the source files from all these languages into a common, very simple intermediate language called CIL, which is basically just go-tos and load, store, and assignment. And then once it's captured all the files in your project, it starts the analysis. And so for each procedure that it found in the source file, it will produce summaries. And if at some point to produce summaries, it will attempt to prove that the procedure has no bugs. And at some points, it will not manage to prove that. And at that point, it will decide whether to report that as a bug or not. So let's dig into the first step, the capture. So here's a simple Java class. Let's look at this method. Compute something. So it tests the flag passed as argument, and it returns either null or something. And the front end will translate this method as a simple control flow graph. So here, obviously you cannot read this, but what you can see is you can see the two if branches, and these are the instructions in each branch. So it's just assigning the string. And then at the end, both branches join to the exit node. So that's it for capture. It does that for all the source files, and it will translate each procedure as something like this. And then the analysis runs on those small CFGs, or big CFGs for that matter. And what it attempts to do is it attempts to understand, to find specifications for them. So what do I mean by that? So for instance, for this method, it will discover that if the parameter is false, then it will return something. And if it's true, it will return null. And so the state before the procedure is called a precondition, and the state afterwards is called a postcondition. And together, they form a specification of the function. So if you start with this precondition and you execute the function, then you will get that as a postcondition. And so for this function, there are two specs because of the disjunct. And then, if we look at the other method, it calls the first one, stores the result into S, then tries to compute S.length. And Infer is smart enough to see that this function depends on the other one, so it will, or if it hasn't already, when analyzing this method, it will realize that it needs to first compute the specs for the other one. So at that point in the method, it will have these two specs for the callee, and we call compute something of true. So it will look which specs make sense for that, and only this one makes sense. So when you call that function with true, you know that it returns null. So at this point, it knows that S is null. And the next line is bad news because you're dereferencing it. OK, that's it. Shit. I did that thing. That's it for how Infer works in its main mode of operation. I want to briefly talk about two other modes of operations. One is eradicate. So in Java, objects can be null. And if you wish it wasn't so, you can use eradicate. So with eradicate, you can annotate objects that can actually be null with @nullable, and everything else will be assumed to never be null. And what eradicate does is it will check that the whole code base is consistently annotated in that fashion. And what that means is, and whenever you dereference something that was marked nullable, then you better have checked for null before, and otherwise eradicate will yell at you as well. And so if you do your whole code base like this, in theory, you should have no runtime null pointer exceptions. So it's more like a type system on top of Java, rather than the main mode of Infer, which tries to really track values. Another mode is for the Clang side of Infer. We have what we call linters, which are simpler check, which are just syntactic and walking over the AST and looking at the node. And what's interesting is you can write your own checkers easily. Either inside Infer, you can add them in Infer if you node, write to camel, or you can even use a simple DSL we have. And I wanted to just show what one of these checkers can look like. So this is a checker, apparently in Objective-C. A property with a pointer type should not be declared a sign, whatever that means. And so the checker for that is just this struct that says when to report, what message to report when the checker triggers, and a fix suggested, for instance. And so when to report is easily expressible here. It's if this is an assigned property, and if it's of pointer type, and if I'm inside an Objective-C property decal, then I should report. So, and you can write quite a range of checkers using this small language. Okay, so now you're convinced, you want to deploy Infer for your project. I'm very happy to hear that, thank you. So how does it work? So at Facebook, when the team arrived, they wanted to analyze the mobile apps. So now we're talking millions of lines of code of Java and Objective-C. And so there was a question of how to do that, how to surface bugs to developers. Because you have this tool that can output a list of bugs, and you have people working on the code base. So the first thing they tried is just run Infer, get the bug lists, and try to be smart about assigning bugs to the right person. I see some people in the room know how that ends. So that didn't work so well. It turns out if anything a couple of weeks old is already history for developers, and so they completely switched to a different task by then. And if it hasn't caused a crash in prod, then they're not interesting anyway. And for bugs reported by static analyzers, it's very hard to know if they're actual bugs or not, because the analyzer only analyzes functions locally, and it doesn't try to start from entry points or things like this. And so the metric here is really seeing the bug. Does the developer think it's worrying enough that he will fix it? So instead, what we found out is we have to integrate Infer inside the development model of developers. So when the code is fresh in their mind, and the best time to do that is at diff review time. So here we have people submitting code for review, and Infer will comment on the code just like the rest of the CI and other reviewers. So I have a thingy for that. So the developer sends a diff, and so this is more or less our setup at Facebook. So we use Fabricator as our code review system. It's also open source. So the diff goes into the CI and to Fabricator. The CI runs a bunch of tests, and one of the things it runs is Infer. Meanwhile, the code reviewers give their opinion on the code, and Infer will try to find issues with the diff. So for instance, let's say it found a bug. Then what the developer will see is something like this, just a message like any other reviewer's message or any other CI message saying, oh, hey, here I think this can be an older reference. And then at some point, everyone's happy, and Infer is happy as well, and the diff goes to prod. So in a bit more detail on the Infer side of what happened here, what happens is under the hood, when we get a diff, we run Infer on the top revision, the one with the diff, with the changes of the developer. And we run it also on the version, on the base revision of that, so before the change. And then we compute only the new bugs, the one introduced presumably introduced by the diff, and we report those. So we don't report all bugs, because as we saw, developers are not really interested in fixing those. And we report only new bugs, and this way this gives high signal to developers that they're responsible for this, they should fix it, or at least find a good story as to why it's not an issue. So for now, these steps are, Infer has no real support for helping you do that. You have to run Infer yourself and do these things by hand, because the business logic to do that lives in Facebook CI and not in Infer itself. But these days we're working on bringing that logic into Infer itself so that more people can benefit from this workflow. So yeah, that's it. So every month Infer runs on thousands of modifications on those mobile code bases, and it reports hundreds of times per month, and that is fixed by the developers. And what I was talking about before, what we measure is the rate at which people fix the bugs. So we want that to be very high, otherwise people will start ignoring the tool, and then it's game over, because once people are trained to ignore your tool, it's very hard to come back. So approximately 70% of the warnings that Infer gives are fixed. And that's it. Thank you for your attention. Questions? Yes?
How well could that work for recursive code? Is that a topic for you at all?
So
it's static analysis, so I wonder how well static analysis would work on that.
So the question is, does it work for recursive code? So you mean mature recursive functions in the code? So in theory, yes. So Infer used to. So in theory, what you do in the theory behind Infer is, when you have mutually recursive functions, you start by analyzing any one of them, and you analyze the others based on the result of that until you've gone around the loop some amount of time and you've converged. And then at some theoretical point in the future, the specs will stop changing. In Infer, in practice, we go around the loop twice, I think. I think that was the previous heuristic. I think now we don't go around the loop. We go around the loop only once. So we start somewhere, we give it an anti-spec, and then we go around. Because in practice, people don't write that many recursive functions, so we haven't found that much issue with it. But if someone wants to, I mean, the theory supports it and the tool supports it. Just a matter of if somebody cares enough about that, they can add that to Infer. Yes?
How do you compute your control flow graph when you have dynamic function pointers, when you have complex loops, equal to external functions that you didn't know, or just for trading?
So the question is, how do you compute control flow graphs, given that there are external functions, loops, function pointers, and dynamic dispatch and the like. So there are several issues in what you mentioned that all need to be tackled, and the answer. So the CFG itself is just another representation of the AST, so it's nothing particularly complicated there. But for instance, let me talk about dynamic dispatch. So when you go to a method call, and you have to do method resolution, and at that point, Infer will track, in fact, the precise type of the object you need, and so it will use that type to figure out which method to call. And what that means, what dynamic dispatch, the biggest hurdle we had to overcome was that the call graph is now dynamic. You cannot first start by computing your call graph of your whole project and start analyzing function in the order, starting from the callees and going to the callers, because you don't know which one is calling which other one. And so the way we cope with that in Infer is we have an on-demand analysis. So when we get to a call site, it could be that we haven't analyzed that function yet because it's dynamic dispatch, and we didn't realize that this was a callee. And so at that point, Infer knows how to stop what it's doing, go analyze the other function, and come back once it's done. But these are all very good, very tricky issues, and we solve some of them, like dynamic dispatch, and we do the same sort of thing for function pointers, but we haven't solved all.
You say you solved some of them, so which of them?
So what was your list again?
For example, multi-threading?
So multi-threading Infer assumes everything is sequential for now. We're starting to develop a concurrency analysis for Java.
All right. When you have calls to external functions.
So calls to external function, that's an interesting one. So we have two approaches here. One is for libraries that are used often and for which it matters. We have models inside Infer, so it knows what's a hash map, what it does, a bunch of things like this. So you can always add more models. And in general, but the basic thing it does is if it finds a function that it doesn't know anything about, then what it will do is what we call angelic mode. It will assume that the function does the best possible thing for the rest of the program. So if it returns an object and you later dereference it, then, oh yeah, it was probably allocated by the function. And doing that, we found we enabled us to analyze a lot more code than when we used to be much more pessimistic. Yes?
So you mentioned that 30% of the defects are not fixed. Is it because of false positive or just that the developer don't care?
So the question is about the 30% of issues that are not fixed by developers. So as I said, it's impossible to know if things are false positive. You could spend weeks on one bug trying to figure out if you can reproduce it or not. So we don't try to measure that. Yeah, I mean, it's not feasible.
Okay. And in the reviews, the developers are going to say, I don't care?
So what we do is, in our team, we have someone look at the bugs that have been ignored by developers in several iterations of their diff. And we go look at those and we have a discussion with the developer to say, oh, why didn't you fix that? It looks like a bug to me. Or, oh, sorry, this is clearly a false positive. We'll try to improve Infer for that case. And so we improve the tool continuously based on that.
Cool.
Yes?
For C, C++, which compilers are supported here?
So the question is which compilers are supported for C and C++? So the answer is Clang and only Clang.
Okay. So you read just the intermediate language for both C and Java.
So
do the analysis not on top of the source code, but
yeah. So to elaborate, so we do the analysis for Clang on top of the Clang AST. So we start from the AST. And for Java, we start from the bytecode. Yes? The question is, can we do Scala then? Yeah, in theory we can, but the thing is we have, I mean, there's no particular difficulty there, but we don't have a mode where we can just give bytecode to Infer and it will analyze it. You have to give the source code. So for now, we're blocked on the, but if somebody wants to analyze Scala, then it shouldn't be hard to add. Yes?
How does it compare with LVM static analyzer, because there is Clang static analyzer?
Yes, so the question is how does it compare with Clang static analyzer? So there are a bunch of static analyzers in the wild, and what we found out when trying to compare them is that they all report pretty much different sets of bugs. So the best strategy here is run them all.
In terms of number, like, does it detect more bugs? Do you run comparison? Because it's kind of obvious question, because using Clang, if people using Clang anyway, they would run a static analyzer there. And
Right.
is it faster?
Right. So.
Is it more stable?
So the question is, but actually answer the question, please. So, so I don't have a very good answer to that. I can point technical differences between the tools. For instance, Clang static analyzer is limited to analyzing a single translation unit, whereas Infer works across translation units. In general, Infer tries to find sort of deep bugs. It's completely interprocedural, so it will find bugs sometimes across long call chains, and I haven't seen that very much with Clang. And we're also not looking necessarily for the same kind of defects. Yes, please.
How do you support string integration and how toward classes?
Pardon?
Do you support string integration and, for example, toward classes?
I'm sorry, I didn't get that.
String integration.
String integration.
What's Spring? I'm sorry, what's Spring?
Java Spring.
I don't know what that is.
You don't know Java Spring.
I'm an OCaml developer. We can talk offline, and you can teach me about Java Spring. Yes, please?
Have you considered rendering the reports in HTML?
Have we considered rendering the reports in HTML?
Plain static analysis.
Yeah, that would be great. So do we plan to port Infer on popular CL tools like Jenkins? So I don't see any real difficulties with that. So I don't think we want to do that ourselves because we don't use it. So that doesn't make much sense. But what we're doing, as I said, is we're trying to put most of the logic you would need to do that inside Infer, like so that you could say Infer diff analysis of this and that, and then it will automatically just compute, do what I said about analyzing the top revision, the base revision, and reporting only the change files. And then the reports from Infer are simple JSON objects, so hopefully someone will write some interface for that. I'm sorry, there was a question. Yes. Checkered. Okay.
I would just to clarify the question from the colleague. Do you support Java Enterprise, annotations, dependency injection, stuff like that?
Ah, right. Sorry. Yes. So dependency, I think all that is resolved before we run because we start from the bytecode. The question was about Java Spring. Yes?
Do you have any IDE support or plans for IDE support?
Do we have any IDE support? Not at the moment. It would be nice to have. Yeah. That's true. We have very good Emacs support, as you could see. No, that is not real IDE support. It's just the URLs are formatted in a way that editors like Emacs understands. But beyond that, there's nothing to put in IntelliJ to run Infer on each change or things like this. That would be nice.
Another question is, what's Infer written in? What languages?
Infer is written in OCaml. It's a functional language. Yes?
You said that you run on diff, just on diffs. Is it implies that you need some data storage for storing some state for previous binary?
Right. So the question is, we mentioned that we run on diff, so does it imply that we maintain some external storage of issues? So not really. So no, because what we do is we really run Infer on the diff and on the base revision. So we run it twice for every diff so that we can do the comparison just locally. So, but the longer story is most of our projects use Buck, and we use the Buck cache to cache the results of the analysis. So it's very often the case that some parts of the analysis results are already in the cache, and we don't need to run Infer for those. Yes, please?
If I recall correctly, I saw one slide where the output from Infer was pushed to a source code management system or review system. Was that correct? Or do you support integration with, for instance, Bitbucket or GitHub, that the remarks of Infer come into the
yes, that was so the question was there was one point where I showed an Infer comment inside a review tool. So it's just integrated with Fabricator, and that's not even Infer talking to the Fabricator API. It's just the CI reading the results from Infer and then talking to Fabricator. So we don't really have this sort of integration, but that's something we're hoping to build. Or build the tools for people to easily integrate like this. Yes?
Yeah, when you showed the slide with the DuckDuckGo code,
Mm-hmm.
there's a lot of commented code. Is that really in there, or did you put it?
Oh, there was a lot of commented code when I showed something. Did I cheat? I don't think so.
Where?
This guy?
No, not this one. Sorry. This one, yeah.
Yeah, you're right. What is that? That might be the fix. More questions? No?
You plans for scripting languages? Is it just about translation, about one language to an intermediate representation?
So do we have plans for scripting languages? We don't have plans for scripting languages. But everyone is welcome to write their own front end for their favorite language and interface to Infer. So the thing is, it's just a matter of writing a compiler from your language to Infer. So what we did, we support 4 languages. Basically, we wrote 4 compilers.
So you have an interface on which we can build the front end on top of Infer.
So if you emit the intermediate language, then you can interface whatever front end with Infer. Yes?
Do you have some times for larger projects like Firefox or LibreOffice or something like that? How long it would take to run on that?
It's not very long.
How does it?
For LibreOffice, it's
So the question is how.
more than a day.
Sorry.
For LibreOffice, Coverity runs more than a day.
Right.
Just get analyzed before.
I don't think I'm allowed to hear information about Coverity, so you know that. What did you say? So the question is, how long does it take on big projects such as Firefox? And I will delegate the answer.
So I'm running it on Firefox, so for Java it takes like 1 hour, a bit less, and for C it's less than that because we don't have much C and we are not running it with C++. So it's, in a CI it's working perfectly fine, and the feedback loop is good enough.
So the answer is on Java it's less than 1 hour. So what in the diff analysis, I can give the Facebook side. On diffs, we aim to report within 10 minutes, and so our P50 is probably around that. Our P95 is much worse because of the deep analysis Infer does. Sometimes a small change can trigger a lot of dependencies, and it also depends how much is in the cache already or things like this. Yes?
You said that you sometimes look at the code when bugs are not fixed and try to figure out why. Do you look when the bugs are fixed and how people fix them in a way? It's more philosophical.
Okay. So the question is, I mentioned that we go look at bugs that people don't fix. Do we also look at bugs that people do fix and how do they fix them? Sometimes, but very anecdotally, because mostly if the bugs has been fixed, then Infer stopped reporting at some point. So we're happy, and we don't really dig much more into that.
But do they, I mean, I'm just wondering, do they write tests to demonstrate the bug, for example, not just to rely on Infer to tell it about it?
Okay. The question is, for instance, do they write tests to make sure the bug is gone? I don't think they do. So these are not runtime bugs. These are, I don't know. I'm not sure. That's a good question. So one thing is Infer will be running on their next diffs as well. And so if it found it this time, it would probably find it the next time. And so maybe our engineers have come to rely on Infer a bit, yes. No more questions? Okay, thank you very much.